problem 3 in the stoichiometry problems. Again, pause here if you haven't done the problem yet. If you're actively taking my course, then you can download it from Canvas. Maybe someday I'll figure out how to put a link in the description. Either way, write this down, try the problem first, and then come back. So let's look at what we've got in our question here. So we've got if this amount of carbon dioxide is produced when burning. Again, we're using the same equation, which is kind of nice. Burning this C7H16. How many liters of water vapor would also be produced at STP? Now, this burning C7H16 is a distractor. We don't need that part of this sentence for this problem. But we are given fairly sparse information otherwise. But that's okay. Now notice here, it says carbon dioxide. It does not say if it's a gas or not in the sentence, but looking at our balanced chemical equation, we can see that it is a gas. So we're probably going to be doing something with gas solids here. We want how many liters of water vapor. That vapor is critical, but also in our balanced chemical equation, that's water vapor as a gas, right? So water vapor is gas, water. So we're going from one gas to another gas volume. So one way we could do this, we've got our volume here for CO2 is 2.555 times 10 to the 4 liters of CO2. What we want to find is the volume, and I'm going to use a subscript here, volume of H2O. What is that? How many liters of water vapor? The other little piece of information that's necessary here is STP. Remember, STP, standard temperature and pressure. Our standard temperature is 273.15 Kelvin. Our pressure is 1 atmosphere. And what else does this mean? This means I can use 22.41 liters per 1 mole to convert any gas. As long as we have these right temperature conditions, I can convert any gas from a volume, liters, to moles. So again, you might be tempted on a problem like this. You see, oh, I've got a volume, and then I'm asked for a different volume. You might be tempted to think of a simple gas law. Maybe you're thinking P1V1 equals P2V2. Well, the problem with that is this would be for the same gas. And here we're going from carbon dioxide, and we're calculating water vapor. So whenever we're doing one compound into another compound, that's stoichiometry. So this is going to be moles of CO2. We use a mole ratio that lets us convert to moles of H2O. And then we can figure out sort of the other units, how we convert to and from. So 2 moles of CO2 and from moles of H2O. I guess later, and now is later in this case. So we're going to use this 22.41 liters per mole. That'll get us from liters of CO2 to moles of CO2, and then we use mole ratio to convert from CO2 to water, and then we can use 22.4 liters again, because now we have moles of water, we can convert that into liters of water. Again, gas. So this only works for gases. 22.41 liters only works for gases. So that sets up the whole stoichiometry problem, 2.555 times 10 to the 4 liters of CO2. And so I have liters. I want to cancel out that liters. So I put the 22.41 liters per 1 mole. The liters goes on the bottom, the moles goes on top. That's moles of CO2 in this case. So now I need my mole ratio. So moles of CO2 goes on the bottom. 16 moles of H2O goes on top. And now on this end, because we're still at STP, it doesn't tell us if the temperature or pressure changes. Still at STP, so I can use 22.41 liters over 1 mole. And that will give me the liters of water vapor. Again, remember you can pause at any time. So 2.555 e to the 4 times 16 times 22.41 divided by 22.41. So did I really need to do either of those 22.41s? Not for the math to work out, but for the units to work out, we did. That's a lot of oxygen, 29,200 liters of oxygen, or sorry, not oxygen, water. Now, that's not in the correct sig figs. So how many sig figs do I have? Well, looking back, or maybe even starting from the beginning, 2.555, that's 4 sig figs. That's the only thing I provided in the question. We used 22.41 liters. That's 4 sig figs. So smallest number of sig figs is going to be 4. So this should be 2.920 times 10 to the 4 liters of water vapor, or H2O gas.